Okay, hello everyone. In this video, I'm going to demonstrate some forces in mechanics of materials, and like in this introduction of this course, the mechanics of material. This course is trying to get a relationship between external load and internal force in the material. When I apply an external loading on a material, in the material itself, it will create internal forces to respond to external loading. And there are some very important internal forces. Okay, so I have to demonstrate in this video the important forces are it's normal forces and shear forces, and also moment. Okay, moment moment is not force. Okay, all right. Okay, moment, and also the last one is torsion. Okay, so let's start from the normal force. Normal force means the force is perpendicular to the area of interest. Okay, for example, well, this is a rubber band. This is a rubber band. Okay, if I apply a load if I stretch this rubber band, okay, like this, I stretch this rubber band. Okay, and because the whole system is statics, okay, I stretch this rubber band with external loading, and actually in this rubber band they will create internal forces to respond to the external loading and make the whole system statics. Okay, don't forget, in mechanics of material, everything is static. That means everything is no translational motion and rotational motion. So when I apply an external loading on this rubber band, there will internal forces respond to this external loading to make the whole system statics. Okay, and the responsive force is the force must be perpendicular to the cross-section area. That means the internal force must be point to this way. Okay, the stretch, the internal force must point to this way. Okay, it must point to this way, and in this way, the force is perpendicular to the cross-section area. Okay, the force is perpendicular to the cross-section area. That's called normal force. Normal force, the force is perpendicular to the cross-section area. And also the same thing if I stretch the plastic pipe. Okay, here's a plastic pipe. Okay, if I make a stretch, yeah, it's hard to see it, but I'm not sure you can feel it. I don't have enough strength. Okay, if I stretch this plastic pipe, there's internal forces. Internal forces point in this direction, and this direction is perpendicular to the cross-section area. Okay, the cross-section area is here, so if I apply an external loading, there's a force point to the left, and this force is perpendicular to the cross-section area, so that's called normal force. Okay, your force is perpendicular to the cross-section area. Okay, that's normal force. Okay, another important force in mechanics of material is called shear force. And shear force, like I say, if I have two plates here, okay, okay, and then if the force is it's the force lying in a plane of area. So okay, so the area is here, and the force is lying in the plane of area. So now this is area, and the force is lying in a plane of area, and then I push this way. Okay, it's called shear force. Okay, this is called shear force. The force lies in the plane of area. Okay, so that's called shear force. Okay, it's called shear force. Okay, and the force is lies in the plane. And there's a play cars very often. This is also called, okay, this is the area. Okay, this is the area here. Okay, and the force is lying in the plane of area. Okay, and it's called shear force. Okay, it's called shear force. Okay, okay, this is called shear force. Okay, called shear force. Okay. Okay, and there is also a shear force in a beam when I apply an external load. Okay, we need a demonstration of the beam. Okay, here is suppose this is a beam. Okay, and then I give him a roller support. No, maybe a fixed support. Anyway, okay. Okay, I just want to demonstrate there was also a shear force in beam. Okay, I think it should be. I'm not sure this angle can demonstrate this. Okay. Okay. Here. Okay, here is the beam. Okay. Okay, here's the beam. Okay, when we have support, if I here is I apply a loading here. Okay, I think it's here. Okay, apply a loading here. Apply a loading here. If I apply a loading here, there will be a shear force in this direction. Okay, if I apply a loading here, and suppose this is a cross-section area of the ruler, there will be a shear force in this direction. There will be a shear force in this direction. If I apply a load here, okay, and there will be a shear force along if this is a profile of the ruler, this will be a shear force in this direction. So when you apply a loading here to a beam, there will be a shear force. Okay, there will be a shear force. There will be a shear. Maybe it's pointing up to respond to external load. But anyway, the force will align in a plane of area. Okay, that's called shear force. Okay, that's called shear force. And okay, that's for shear force. And also this keep continue on this beam. If I apply a load here, it will create a moment. Moment will bend the beam. Okay, suppose if I apply a force here, okay, they apply a force in this way, this will bend. Okay, this will bend. Okay, if I apply a load here, okay, it will bend this beam. Okay, and you apply a loading here, it will bend this beam. So that's called moment. Okay, this will moment. So the external load will create a moment in the material and then bend the material. Okay, maybe this is not obvious. Let's use the car as an example. Okay, if I apply a force here, okay, it will bend. Okay, this force will create. If I apply a loading here, it will create a moment. A moment will bend this material. Okay, like this. So on the other side, if I apply a force here, you create a moment and bend the material like this. Okay, this is called moment. Okay, bend the moment. Okay, this is called bend the moment. Apply a force and bend the bend the material. Okay, and okay, the last one is torsion. Okay, torsion is just a twist. Okay, torsion is a twist. This one can twist. Yeah, this car, if you twist it like this, I think it's like this is called it's not obvious. Okay, so maybe we have to switch back to this plastic. It's called twist. Okay, it's called twist, and twist is caused by torsion. So this is the torsion. I apply a torsion to the material. Okay, this will create a torsional moment. Okay, apply a torque, apply a moment to this material. Okay, or torque. Okay, I think I should be better or more precise. Torsional moment. Okay, I provide an external load of this material, but external load is looks like this way. Okay, look like this way. Okay, and this will give you a torque, and the torque will make the material twist like this. Okay, you see the material is a twist. Okay, if I apply a torque, okay, and then I can apply a torque in this way, you'll see the material is going to twist. Okay, okay, so this is called torsional moment. Okay, torsional moment to make the material twist. Okay, apply a torque, make the material twist. Okay, so that's the 4 important force and moment in the when you apply external load to a material: normal force, shear force, and moment, and torsional moment. And in the following course, we will talk about how to calculate. Okay, how to calculate this internal stress. Okay, we will introduce the internal force first, and then go to internal stress, and then go to the strain. Okay, so that's probably the most important thing in the mechanics of material. Okay, so I hope this video will just show you give you an idea, or give you a picture of what these forces are. Okay, so normal force, shear force, and the bending moment, and the torsional moment. Okay, so I just stop a video here. Okay, and see you in the next demonstration. Okay, bye bye.